Hello, welcome to episode 4 of Multivariable Physics. Today we're going to be doing the chain rule. And so I'm going to be looking at two examples. So we're going to look at what happens if we have a scalar function and a vector function. Okay. And two scalar functions. So this first one is very easy. So this blue one, the second one is actually pretty easy. So this one, in this case, what we can notice here is that this is so g is a function that has it takes one variable, right? And then, so it's a function of r to r. And then f, okay, is a function of rn to r. So if we take this, if we only have, this only has one dimension, all right? One parameter. G only has one parameter. So if we take then this sort of nabla, or the gradient of a single variable function, well, that's just the derivative. We're going to just get, nabla g is equal to what, this vector d over d whatever, so g of x, right? It's gx of g, and that's it, right? So this is just the derivative, d over dx, right, of g. And then x is going to actually not be x, right? But so all this is well, we just apply g prime of f of x, right? And then we multiply, and then now what we need to do is actually do take this. So it's the same rule here. Now we just put this nabla off to the side. Okay. Right, so that's pretty simple. That is equal to nabla g f x. This second part though is a little trickier, because here we're taking, we have f of gt, so I'm going to define g is equal to x1 of t, x2 of t, dot dot dot, and then we have this gradient. Well, what we're going to be getting is, if we try taking the gradient of, and first of all, I haven't even talked about what it means to take the derivative or gradient of a vector valued function, and that's for good reason, because it kind of makes more sense when we talk about other stuff. But right now we kind of just jump right into it. And so kind of the big thing here is to remember this in this, right? If we have d over dxi, right? So at every point, let's just think about what one point is, right? Nabla f is going to just give us prime over, so we have to basically just do this, right, for every xi, right? Every xi in G, we just take this derivative through it, right? And then, since this is obviously a single variable function, this is a single variable function, or no, well, technically it's a multivariable function, right? But it doesn't spit out a vector. So we remember what happens if you take the chain rule on something like that. Well, then we just want to take this plus, f of f over dj, or xj over t, right? And we do that, and we basically just take all of these massive sums. So you end up with something like this, you know, df over dxi1 dx1 over t dt plus dot dot dot, right? This is going, and if you notice, right, this is just so this is taking partial over partial t of f gx of t, or gt in this case, right? We can, ends up with this really long sum, and we can actually kind of split this sum up, because if you look at nabla f, it's going to be, well, this is just delta f over delta x1, delta f over delta x2, right? So on and so forth. And if we think about what g prime is, and then g prime, this only has one variable, right? So I technically haven't spoken about what happens if you take just the regular derivatives, but since this only has one variable, this is a vector valued function, but it has one variable only, right? So we don't need to take the gradient. We can just take d over dt, right? Of g, well, this is just d over dt x1, right? Of t. D over dt x2 of t, right? So this is that's g prime of t, right? I'm going to get into all this a lot more in the next episode, but so we have these two equations, and we can actually build this sum from both of these, because this is just the dot product between both, right? So you can think of this as belongs to here, this belongs to here, you know? So this is actually the dot product of delta f dotted with g prime of t. And so that is what delta f of gt is. And another, usually a way to write this is nabla transpose, because remember, nabla is a vector, g prime t. Alright, so hopefully that made sense. If there's any clarifications, I don't know, comment or something like that. And yeah, see you in the next episode, where I will actually talk about this 4.a. I'm going to probably go into actually taking derivatives in vector value functions, because I realized I didn't actually cover that in the last episode. So thank you for watching.